Alright guys, so yesterday we talked about the distance formula. We derived it, essentially an algebraic proof for it. I want to do the same thing today with the midpoint formula. Okay? So knowing what the midpoint formula is, or does anybody know what the midpoint formula is? Amy?
Seven.
Yes. So I'm just going to write capital M for midpoint, and it's going to have coordinates that are unordered pair, X, Y. And the way that we find those is that we take the ordered pairs from both endpoints. We take the coordinates from both endpoints, and we add the x's together and divide by 2. And we add the y's together and divide by 2. Now this is a formula on like the 3rd day of geometry back in some of you the 9th grade, some of you the 10th grade. We talked about, we discussed. And this is where I kind of think maybe sometimes the things that we provide you in a math class are kind of backwards, where we learned it, we've used it before, but we haven't been able to have the math or acquired enough math at that time to really understand where it came from. Okay? And as we go through the proof, you start to find out that, all right, it kind of makes sense that on the 3rd day of math class in geometry, we were able to use this proof, but it wasn't until like maybe December-ish that we actually started to be able to recognize why maybe this proof would have worked back then. Okay? And we never really went back and proved this, but I want to walk you through these types of things. This is referred to sometimes as analytical geometry, in which we're going to kind of link some ideas together and then determine algebraically that formula is accurate. Okay? And this is something that we do a lot with the formulas that are presented to us throughout the course, because I think it's important for you not to just understand what they are and how to use them, but where they come from. Okay? And I think if any of you, if just one of us at some point goes on to a college math course other than this one, you're going to see that at times you're going to be asked to do proofs. And a lot of times you're not taught necessarily how to do them. Okay? It's sometimes by those professors, they think you already know how, okay, or that it's just something that comes to you. And it takes practice. It takes seeing this kind of stuff and doing it over and over again before you start to get real good at it. So I want to do that as we start seeing some of these formulas, the ones that we can mess around with. I want to do that. All right, so we got and I'm just going to keep everything here in the first quadrant because I'm going to make some assumptions that I think are going to be beneficial to us in regards that every one of our coordinates up there is a positive number, which is going to be beneficial for some of the algebra that we do here in a little bit. I think you guys would probably agree that if I'm going to do some algebra, dealing with positive numbers is always easier than dealing with negative numbers, right, in regards to my operations. So I'm just going to make that assumption. And then when I make that assumption and we go through the work, the algebra doesn't necessarily know that x1 was a positive number. x1, the algebra could anticipate that it was a negative number. Does that kind of make sense? Okay, because it's arbitrary as x1, it's arbitrary as x, it's arbitrary as x2. Okay, so we're going to go through this information kind of that way. I've set up those ordered pairs using that system there of x1, y1, xy, x2, y2. You could use anything. You could go A, B, C, D, and E, F if you wanted to. Okay. It doesn't matter, but for our formula and the way it's presented with the variables that it has, x1, y1, x2, y2 makes sense. Okay, so we are setting this up and we are making the distinction that M is a midpoint. Okay, M is a midpoint of segment PB, and if that's the case, obviously we have some congruence there, right? Okay, so those marks there mean inside those segments. Now, what we have to do, guys, is we have to create some other things in this to make a connection, and it's a geometric connection that's going to allow us to develop some equations. So the first thing I'm going to do is I'm going to add in here a line that goes through P. Okay? Now that line could be of any slope that it wants to be. But I'm going to make it a slope that is undefined. I'm going to make it horizontal. Or sorry, not undefined, 0. I'm going to make it a slope of 0. And the reason I want to do that is because horizontal and vertical lines are so much easier to deal with than what lines with non-zero or defined slopes are. Okay, so we're gonna go with that horizontal line. Is that all right, everybody? Okay. Now, how many lines? Think about this. How many lines go through M? Just in general, how many lines can we draw go through M? An infinite number, right? We can draw any line that we want to go through M. How many of those infinite lines that go through M are going to be parallel to that dotted line? How many? Just one. Okay? There is one and only one line that goes through a point that is not on a given line and is parallel to that given line. Okay? If you remember that from geometry. Okay? So, I'm going to draw that line that goes through M. Oh, that's not it. Okay? Goes through M. So those two lines, those two dotted lines right now are parallel. Everybody agree with that? If those two lines are parallel, then that segment PB, you guys remember the term that we use, the vocabulary word we use for that line, PB, in regards to the parallel lines? Start with a T. That's transversal. Okay? And when parallel lines are cut by transversals, you start getting congruencies, don't you? Okay? If we were to look at that angle right there and that angle right there, those two angles are congruent. Okay? So that's a huge thing for us right now, that we get those two things to be congruent. Okay, so now, how many lines go through M that are going to be perpendicular to, let me just color this line. You guys see that green? Do it that way. How many lines go through M and are perpendicular to that green dotted line on the bottom? Just one, right? Okay. I'm going to draw that one line in. Okay. I believe it's that line there. So that would be that line going through M, perpendicular. Okay. Now I'm not really all that interested in that whole line. I'm only really interested in that line from M to D. So that portion. Okay. How many lines go through B? How many lines go through B and are perpendicular to that top dotted line? Just one, right? Okay, same idea. So we'll draw that one in. And again, I'm only really interested from B down to that dotted line. So I'm only interested in that. I think that point is E. Now here's a question to think about. Those two horizontal dotted lines were parallel, right? Those were parallel. Okay. This line was perpendicular to one of them. This line was perpendicular to one of them. What's that tell me about the two red lines? They're parallel. Okay. Two lines that are perpendicular to the same line are parallel to one another. Okay. So both of those are perpendicular to either the top dotted line or the bottom dotted line, doesn't matter. And then that means that the two red dotted lines have to be parallel to one another. Why is that important? Think about this. If those two things, I'm just going to kind of go in reverse here, get rid of that one and that one. If the red dotted lines are parallel, what kind of segment is PB for those parallel lines? Starts with a T again. It's another transversal, right? So if that's a transversal, isn't it a true fact that this angle here and that angle there should be congruent? Now I'm not going to fill those in, but those would be corresponding angles, and they are indeed the same. Okay? So why is that beneficial to us? Let me put in that. Let me put in that. Okay? We have two triangles now, right? And we have also stated that angle is congruent to that angle. Do we see that triangle PMQ, sorry, PMD, I'm on my alphabet, PMD is congruent to triangle MBE by angle, side, angle. You guys remember that kind of stuff from geometry? And maybe we're not excellent at that stuff, but it's in there somewhere. Okay. All right, so that's fantastic. That's awesome. Those two triangles are congruent. And if those two triangles are congruent, what's that tell you about the distances of PD and ME? They should be the same. Okay? And DM and EB, those vertical lines, those red dotted lines, those should be the same as well, right? And the reason those are the same, I'm going to write that PD is equal to, or the length is equal to ME. Do you guys remember CP, CT, C, corresponding parts of your triangles are congruent? Okay? So that's the reason those two things are the same. All right? But what's nice about that is that those distances are the same. So if those distances, guys, are the same, we should be able to do something pretty interesting here. Okay? I want to identify some coordinates yet. Before we go along with our algebraic component of this proof, we need coordinates of D. Okay? What is the, and this is all going to happen based off of looking at, let's see here, that point, and that point. Let me, all right, if we look at the blue coordinates, all those blue coordinates, we should be able to find ordered pairs for D and E. Okay? So I'm going to ask you, what should be the coordinates for D? What would be, if this is the origin here, okay, how do I get to D? Based off the blue things, how far over do I need to travel to get to D? It'd be X, right? Isn't D vertically aligned with M? All right, we knew that this was a right angle here. That's the way we set this up. So that's why I wanted to use horizontal and vertical lines when we went through the original process here. And so I can easily find out what D is. Okay, so that's going to be X. Okay. Now, what would the y coordinate of D end up being? Y1. Okay. So X comma Y1. And now let's look at E. E is going to have an X coordinate of what? X2. And what's its Y value going to be? Just Y. Alright. And what is nice about that then, guys, is that we now have the ability to substitute into that equation that we say is PD equals ME. We have the ability to substitute some algebra now. Okay? And this is another reason why one of these lines can be horizontal. We have the ability to find that distance right there. It's a horizontal line. How do you find distances of horizontal lines? You do what? You subtract the x values, right? Okay? And the reason I want to do all this in the first quadrant is because now I know that that x value to the right is bigger than that one. So I'm just going to write x minus x1. X minus x1. And that should give me the distance from P to D, right? Okay. Well, if that's the case, then NE, I should be able to do a similar procedure with NE. Okay, so I'm going to look at those coordinates of x2 and x, right? I'll subtract those. x2 is to the right. I'll make that a larger value and subtract from the smaller one of x. And now I've got an equation. How many variables do I have in that equation? I only have one letter, right? But x sub nothing is a variable. X sub 1 is a different variable. X sub 2 is a different variable. So I've got 3 total, right? Think about this. What are we trying to do? We're trying to find the coordinates for the midpoint. we're trying to find that coordinate for our midpoint. So I'm going to look at this equation and solve for x. Okay? Well, that means I got to isolate it, so I'm going to add x to both sides. 2x minus x sub 1 equals x sub 2. Maybe you're foreshadowing a little bit. You're seeing, oh, I'm starting to see this thing generate itself. Add x sub 1 to both sides. And now divide both sides by 2. And that is then the derivation, the creation of the algebraic proof of the x coordinate for a midpoint. Okay? Now can I do the same thing for the y coordinate? Yeah. Okay, now the y coordinate is going to say that dm is the same thing as EB. Alright? And because I'm in the first quadrant, when I find dm, I'm going to go from the larger y value, which is y. Okay? That y value is bigger than that one, right? Graphically. So y minus y1 equals then, if I go over to EB, be y2 minus y. And again, just like over here, we solve for that coordinate. Now we're going to solve for that coordinate. Solve for y, same algebra, add y to both sides. And now that 5% is 2. And we now have the formula for finding the y coordinate of the midpoint. Is that okay? All right, now I'm not going to ask you right now to reproduce that, but I think that's, the algebra is not all that difficult, but it does maybe jog your memory a little bit with the geometry. And first couple days, I like this exercise because if you remember back to geometry, I would tell you all the time, you're going to need this information down the road in other courses, okay? This is an example. We're going to see a lot in this course that our geometry skills are going to be tested, okay? As much as your algebra skills are going to be tested, all right? Because it allows us to develop a lot of these relationships. Without the geometry, we don't have these relationships to be easily developed like this. Okay. Questions on that? I like doing that more than I like right now doing like practice problems with you because I think for the most part you guys are probably going to be okay with a lot of the practice problems that we do in the examples. But I do want to do maybe 2 or 3 practice problems with you over this stuff. And they're going to kind of model maybe some problems that you see on some tests and quizzes in the future. So here it says which of the points 1, -2, 8, 9 is closer to 5, 3. Every year I give this question on a test or quiz, and it's usually about 1/3 of the people get it wrong because they just start seeing, okay, I'm going to find length. Second.
Huh?
All right, they say I'm going to find the length of PQ and I'm going to find the length of QA. Because they see it, those are, they take the first 2 order pairs, find its length, take the second set of order pairs, find its length, and they compare them that way. Without a sketch, it might be problematic for some of us to realize which segments we need to find the length of. Okay? So, when you draw a sketch, obviously you've got your options and your preferences. My preference is not to really be all that accurate with my scale. Okay? Obviously, I'm going to make 1, -2. I'm going to put that in the right quadrant, so 1, -2 might be down here. Q, 8, 9, that's going to maybe be up here somewhere. And then A at 5, 3 maybe there. But obviously I didn't count over any distances, right? Because I'm not really so much interested in being real precise about things. I'm more interested in just making sure this is organizing my thoughts to tell me that the two things that I'm going to be looking for, the two distances, are PA and AQ. Okay? I don't ever have to find the distance PQ here. Does that make sense? Where that's where most people would go wrong on a test or quiz. If they got it wrong, they probably found distance PQ, then found distance QA and compared those. All right? So we want to find length PA. If you remember from yesterday, okay, basically what we're going to do is to find PA, we're going to take the x values and subtract them, and then square them. And it doesn't matter the order. I always try to keep it so I always do the order so I get a positive number. So I'm going to go 5 minus 1 instead of 1 minus 5. I think it's a safe thing to do. So we'll get 4. I'll square that and get 16. And now we'll do the same thing with the y's. So 3 minus negative 2 gives me 5. Square that and get 25. That gives me root 41. And that should be prime. So I'm going to simplify. That's something we can do? Alright. Take a minute on your own and go ahead and find AQ. So we hopefully got 8 minus 5 give you 3. Square that you get 9. 9 minus 3 gives you 6. Square that you get 36. Sum those together, you get 45. Root 45. So, which point is closer to A? P. Okay? Because to go from P to A, I gotta go to root 41. And from Q to A, I go root 45. 45 is bigger than 41. So, root 41 is the smaller distance, so A is closer to P. All right. Just one thing I have seen people, because we get in a habit of doing this, which is good, is that people say, okay, well that's radical 41, and maybe even we use our calculator. Our calculator does this for us instantly, and it changes this to 3 root 5. Is that easily comparable to that in those formats? No. If you're going to compare distances and there's roots involved, don't simplify either of them, because you're not going to be able to easily make the distinction. Okay. If you change them both to decimals, then okay, that's fine. But that's more work than what's necessary. Okay. If I'm going to compare things on a number line, I usually like them to be in the same format, right? Okay. So, is that all right, everyone? Okay. There's other maybe ways you could have done this because of the integers. Maybe somebody could say, well, here I'm going over 4 units, okay, which is where this 16 eventually comes from. And then here I'm going up 5 units, which is where that 25 comes from. And then over here you say, well, from here I'm only going to go over 3, and here I'm only going to go up 6, okay? So you might say, well, that's, 5 and 4, that's 9 units. This here is 9 units as well. So some people might argue that they're the same, okay? But I would get to the point where if I did it that way, maybe determining the right answer is to then use the Pythagorean theorem, right? A squared plus B squared equals C squared. But is that not the same thing that we did here? Is the distance formula from what we talked about yesterday, the Pythagorean theorem? Okay. So there's options there. I don't know if this is a great thing to do, especially when maybe instead of this number being 1, maybe it's pi. Because now you can't count over very accurately, right? Okay, so just be careful if you're going to use shortcuts. That it works with the types of numbers you're using. All right, so that being said, let's do a midpoint question. Okay, again, sometimes in my PowerPoints, guys, I've put these blue blocks because if you move them, all the work is there. But I don't want you guys to see all the work before we do them in class. So that's something to think about at home. To look at the PowerPoints. All right, so we're going to draw this quadrilateral. It says vertices at 1, 2. Again, I'm not really too concerned about the scale. Just want to make it somewhat accurate. 4, 4. We got 1, 5, 9. So that might be up here. And then S is at 2, 7. So maybe S is there. All right, that's your quadrilateral. Okay. Now our goal is to see, do the diagonals bisect each other? What would be one of my diagonals up there? PR. Okay. PR is a diagonal. What's the other one then? Okay, so let's logically think about how we're going to do this in the most efficient way. Did you guys know slope and that kind of stuff? You could use slope to get yourself there in regards to determining, yes, this is a parallelogram or not. But they dictate that we want to do it by using a diagonal. Okay? So if the red one bisects the blue one, what is the red one going to pass through on the blue segment? It's what? It's midpoint. If the blue one bisects the red one, okay, if the blue one bisects the red one, what's the blue one going to pass through on the red one? It's midpoint, right? So these two segments, how many times do they intersect? One time. So if one of them is intersecting the other one at its midpoint, and the other one is intersecting the first one at its midpoint, but they only intersect one time, don't they both have to intersect at each other's midpoint? So can we calculate the midpoint for both those red and blue lines? And if they are the same point, we show that they intersect at each other's midpoint. Okay. So we're going to find the midpoint of our RP or PR. PR's midpoint. Okay, PR's midpoint. Remember, all we got to do is add the x's, divide by 2, add the y's, divide by 2, right? So if I add my x's, what do I get? 6 divided by 2, you get 3, right? Now I'll take the y values, 2 and 9, add those together, what do you get? 11, and then divide by 2. And you just leave it at 11 halves. You're going to find out in this class, guys, we're not going to want 5.5, okay? Mixed numbers are not anything we want either. We're going to go with improper fractions. So PR midpoint 3, 11, 2, 11 half. Now we're going to do the same thing for SQ. SQ's midpoint. And the hope is that we get the same thing. So we're going to take, I'm trying to do that. So 2 and 4, right? 2 and 4, we're going to add those together. Get 6 divided by 2, you get 3 again. And now 7 and 4, add those together gives you 11 divided by 2. And because those two things are the same, that's telling us that both segments intersect each other at both segments' midpoints. Okay? If they were different, it would mean that one of them is bisecting the other one, but they're both not bisecting each other. Does that make sense? Okay. So if you can do that, I think you've got maybe a good understanding of midpoints. One of the most common questions, and you've done this, you did this in geometry, is something like this. Okay? This will be one of the last ones we do. It says M is the midpoint of AB, M has coordinates of 4, 8, and A has coordinates of -2, 9, find the coordinates of B. Okay? M is the midpoint. M is what our formula is set up to solve for. And right now, we know what that is. Usually we don't know what that is. Usually in the last one, we were being asked to find those coordinates. Now we know what they are. A is like your x1, y1. Does that make sense? That's one of your endpoints. B is like your x2, y2. You don't know B. You're looking for your other endpoint. Okay? Again, I think it's beneficial to draw a rough sketch. Okay, so M is at 4, 8. Maybe that's right there. A, I've got negative 2, 9. Okay, so like I said, this is an endpoint. That's x1, y1. This is your midpoint. That's xy for our formula. Okay, so I know that distance, but I don't know where B is. B is going to be somewhere in that circle, right? Now, this is the reason I like to have the sketch here. When I'm done, I should know that B has an x value that's bigger than 4, and it should have a y value that's smaller than 8. Does that make sense, everybody? Kind of using the slope and stuff of A to M to project what the potential values of my other point, my other endpoint are going to be. All right, so this is how we do this. We know the midpoint formula for x comma y is equal to x1 plus x2 over 2, y1 plus y2 over 2, right? This x value right here is found with that expression. So there's an equation. It says x is equal to x1 plus x2 over 2. Do you have enough of those things? Do you have 2 of those 3 variables? Do you know what x is? X is 4, right? Do you know what x1 is? Negative 2. Do you know what x2 is? B's ordered pair is x2, y2. So no, we don't know that one. Okay? So it's going to be negative 2 plus my unknown, there's my variable, and then divided by 2. We'll multiply both sides by 2, and then we'll add 2. And that should give me x of 2 is equal to 10 once you solve that. Wait, I'll leave you guys to do that on your own. Is that something we can do? You guys recognize that? Okay. And like I said, we've done that in the past. We did that in geometry. Okay. But I'm going to take this a little bit further than what we did in geometry here in a moment. When we go with y1 plus y2 over 2 to solve for that y value. So that y value is our 8. So we'll say 8 is equal to y1, which is 9, plus y2 over 2. 16 is equal to 9 plus y2. 7 is y2. So the ordered pair of B is 10 comma 7. And then we'll go back to what I said before I started doing the problem. My x value should be bigger than 4. Is it? Yep. My y value should be smaller than 8. Is it? Yeah. So that's giving me some confidence that I've done things correctly. Okay? If you want to go a step further, make sure that you did it correctly, you could maybe find the distance of that using distance formula. Find the distance of that using distance formula. Make sure you equate to one another, and that will tell you. I'll let you try out a midpoint as well. Okay? There's an easier way. Think about this. There's an easier way. And the reason that this is an easier way is because all my coordinates are integers. Okay? It does not work when I have non-integer numbers. But how many units do I got to go down to get in line here with M? You got to go down 1, right? How many you got to go over? 6. Okay? Now think about the picture that we started with at the beginning of class, and maybe I can pull it up here. We did that, right? What are those two triangles to one another? It's congruent, right? So should I be able to go, what, down 1 more? So if I start at 8 and go down 1 more, where would I be? 7. If I go over 6 more, where am I going to be from 4? 10, right? So you could use just a counting technique there. Rise and run, essentially, to find those locations of that endpoint. But that doesn't work when we have something like this. All right, so if I have A to be located at, let's just go square root 7, and let's say that the y value is at 2 pi. Okay, so I'm going to write here that this was root 7 comma 2 pi. Let's say M, my midpoint, is at, let's go 2e, comma, I don't know, root 13. Okay, 2e root 13. Okay, again, that's the midpoint. So I'm looking for b's coordinates, and they're going to be down there somewhere, right? Does that kind of make sense? But can I accurately count now? No, I might be in the ballpark, okay, but I'm not going to be able to accurately count, because every one of those numbers I gave you up there is an irrational number, okay? It doesn't repeat, it doesn't terminate, so counting is going to be a problem. Even if I just gave you fractions, and maybe fractions that did terminate, okay, it's still going to be a task, and that's why we've got to have these formulas. So if I've got, if I'm looking for my x coordinates, so remember x was x1 plus x2 over 2, okay? Well, x1 is root 7, okay? x2 is my unknown, and then x, that's the coordinate of the midpoint, right? That's 2e. Okay, e is about 2.8. Okay, it's a natural number. You guys did it with logarithms last year. Okay, so it's a number like pi, a trait like pi. Multiply both sides by 2, so it gives me 4e is equal to root 7 plus x sub 2. And now subtract root 7. And there's the x coordinate of that other midpoint, or sorry, of that other endpoint. Okay. Now I can't combine those. Those are two irrational numbers that don't have any characteristics in, or similar characteristics to where I can combine them or anything like that. That is the best way of writing that distance, that coordinate. Okay. I'll do the same thing with y. So y equals y1 plus y2. Okay. Again, the y coordinate of my midpoint is root 13. y1 I said was 2 pi. Okay, so now I'll go 2 root 13 is equal to 2 pi plus y2. So 2 root 13 minus 2 pi is equal to y2. So my ordered pair for b, b's ordered pair is going to be 4e minus root 7, comma, 2 root 13 minus 2 pi. Not a really cute, fancy number that really works real nice for us, but it's exact and it's accurate. Okay, so if I just ask this thing to find that location, I can go 4e minus root 7 comma 2 root 13 minus 2 pi. They'll put b in here. And you see where b is located. Does that look like m is in the midpoint? And if I ask it to find distances, a to m, 3.87, b to m, 3.87. Okay? Now 3.87 is rounded to 2 decimal places. It is an irrational number as well. Okay? Does that kind of make sense, the reason for the formulas? Because sometimes shortcuts work. It's great if you know what's going on and you know the situations in which you can use a certain approach, use it if it's easy. But there's also situations where you know that I can't use that approach and I have to rely on the formula. The formulas are always going to be kind of the catch-all. They will always get you the right answer. Sometimes it maybe in that first example we did, it wasn't really necessary to do the formula. It was more work. Here, it's not. This is the simplest way of finding those exact ordered pairs. Okay. WebAssign is